Right now, drifting through our solar system on a path that will never bring it back, there's an object older than the sun itself. Not older than the sun burned brightly, older than the sun existed at all. While researchers were analyzing the newest data pulled from the James Webb Space Telescope, they found themselves looking at chemistry that, according to every model of how comets are supposed to form, should not exist. This is not an object from our solar system that wandered somewhere strange. It was never ours to begin with. It arrived from interstellar space, passed through the neighborhood of the sun for the first and only time in the history of our solar system, and is now leaving forever, never to return, on a trajectory that will carry it back out into the galaxy within the next few years. Only 3 objects like this have ever been detected in the entire history of human astronomy, out of the countless comets and asteroids cataloged across centuries of observation, meaning astronomers have averaged roughly 1 confirmed interstellar visitor every 4 years since the very first one was ever recognized. The third one is the strangest yet. Its name is 3I Atlas, and the deeper scientists look into what the James Webb Space Telescope has captured, the stranger the story gets, to the point that one of the most respected astrophysicists at Harvard University has publicly refused to rule out an explanation most scientists consider far outside the mainstream. This is the story of what Webb actually found, what it means, and why the debate over this object is nowhere close to finished. I am your name, and this is your channel. Subscribe now if you want more stories like this, because we are just getting started. Let's start with what makes an object like this so rare in the first place. Every comet and asteroid you have ever heard of, Halley's Comet, the asteroid belt between Mars and Jupiter, even the icy bodies out past Neptune in the Kuiper Belt, formed here, inside our own solar system, bound to the sun by gravity for the entire span of their existence. An interstellar object is something completely different. It formed around a different star, in a different planetary system, possibly billions of years before our own sun ever ignited, and was eventually flung out of its home system entirely, ejected into the vast emptiness between stars by the gravitational influence of a passing planet or a near collision nobody will ever be able to reconstruct. From that point forward, it simply drifts for millions or billions of years through the emptiness of the galaxy until, by sheer chance, its path happens to intersect with a star system that has telescopes pointed outward and scientists paying attention. The first confirmed interstellar object, named Oumuamua, was detected in 2017, tumbling through our solar system on a hyperbolic trajectory that immediately marked it as something that did not originate here, and its strange elongated shape and unexplained acceleration sparked years of debate that still has not fully settled, with a small minority of researchers continuing to argue its properties were never fully explained by any purely natural model. The second confirmed visitor, named Borisov, arrived in 2019 and behaved much more like a conventional comet from the moment it was detected, displaying an obvious tail and coma and a chemical composition that, while still foreign to our solar system in its exact proportions, fit comfortably within the range of what astronomers already understood comets to be, easing some of the mystery that had surrounded the first discovery. Then, on July 1st, 2025, an automated sky survey system called ATLAS, built specifically to scan the sky for exactly this kind of object, caught a faint, moving point of light that did not belong to anything cataloged in our solar system. Follow-up observations confirmed it within days. Humanity had found its third confirmed visitor from beyond the solar system, and this one was moving on a trajectory that would carry it through the inner solar system, close enough for our best instruments to actually study it in detail before it disappeared again forever. That is where the James Webb Space Telescope enters the story, and where things start getting genuinely strange. On August 6th, 2025, just over a month after discovery, astronomers turned Webb's near-infrared spectrograph instrument toward 3I Atlas and captured what would become its first detailed chemical readout. What came back immediately stood out. The comet's coma, the cloud of gas and dust that forms around a comet's icy nucleus as it warms and releases material, was dominated overwhelmingly by carbon dioxide, at a ratio compared to water that researchers described as one of the highest ever recorded in any comet, anywhere, at any time. For comparison, comets that formed inside our own solar system typically release much more water vapor relative to carbon dioxide as they warm. Finding a comet this heavily weighted toward carbon dioxide instead suggested something fundamental about where and how 3I Atlas actually formed, hinting that its parent star system may have had a very different balance of ices in the region where this object first came together, likely much farther from its star, in a colder environment, or exposed to a different intensity of radiation than anything typical of our own solar system's history. Alongside the carbon dioxide, Webb's instruments also detected water ice, carbon monoxide, and a distinctly unpleasant-smelling compound called carbonyl sulfide, adding up to a chemical fingerprint unlike anything previously cataloged from an interstellar visitor. Then, in December 2025, as 3i Atlas made its closest approach to the Sun and began heating up dramatically, Webb turned toward it again, and this time, the results reached even further back in time than anyone initially expected. As the comet moved away from the Sun afterward, freshly warmed and outgassing brightly, astronomers captured a new round of extremely detailed measurements, this time analyzing not just what molecules were present, but the specific ratios of different isotopes, subtly heavier or lighter versions of the same elements, locked into the ice. Those ratios function almost like a fingerprint of age and origin, because the balance between them shifts depending on the conditions under which ice first formed billions of years ago around a completely different star. When researchers finished analyzing that data and published their findings in the peer-reviewed journal Nature in June 2026, the estimate they arrived at was staggering. 3i Atlas, they concluded, likely formed somewhere between 10 and 12 billion years ago. For context, our own Sun and solar system are roughly 4.6 billion years old. The object currently drifting past our planet's neighborhood may be more than twice as old as the Sun itself, potentially formed when the universe was barely a quarter of its current age, around a star that may have died, exploded, or dissolved into the galaxy long before our own Sun ever condensed out of its birth cloud of gas and dust. This is not simply an old rock. It may be one of the most ancient physical objects ever directly measured and analyzed by any instrument humanity has ever built, a genuine relic from an era of the galaxy that existed before our own solar system had a single planet. And then, just weeks before this video, Webb added one more piece to the puzzle. Using its mid-infrared instrument, an entirely different detector tuned to a different range of the infrared spectrum than the earlier observations, astronomers collected what NASA described as the first mid-infrared chemical fingerprint ever obtained from an interstellar object, observing the comet on two separate dates as it continued its journey back out of the solar system. That new data, published in the astrophysical journal Letters, confirmed the detection of methane venting from the comet, another data point in an already unusual chemical profile, and one more piece of evidence that whatever process built this object, deep in the history of some long-gone stellar nursery, followed a genuinely different recipe than anything that assembled the comets native to our own solar system. Stop and sit with what that 10 to 12 billion year age estimate actually implies, because it is easy to read past a number that large without absorbing what it means. The Milky Way galaxy itself is estimated to be around 13.6 billion years old. An object that formed 10 to 12 billion years ago did not simply predate our Sun. It formed when the galaxy itself was still young, when the population of stars available to build planets and comets around looked nothing like the neighborhood we live in today. Researchers studying 3i Atlas have suggested its chemistry may be consistent with formation around a star belonging to the galaxy's thick disk, an older, more slowly rotating population of stars that formed early in the Milky Way's history, long before the thin, flat disk containing our own Sun and its neighbors had fully settled into place. If that origin holds up under further study, 3i Atlas is not simply a visitor from another solar system. It is a physical time capsule from an entirely earlier chapter of galactic history, ejected from a star system that may have long since burned out, exploded, or scattered its remaining planets into the dark, drifting silently for billions of years until a chance alignment brought it close enough for a telescope built by a species that did not exist for nearly all of that journey to finally take notice. Here is where the story takes the turn that most headlines never explain properly. Because alongside all of this careful, peer-reviewed spectroscopy, a separate and far louder conversation had already been running since the week of the comet's discovery, driven by one of the most prominent and controversial figures in modern astrophysics. Avi Loeb, a Harvard astronomer and the former chair of Harvard's astronomy department, published an essay within days of 3i Atlas's discovery raising a question most of his colleagues consider far outside the scientific mainstream. Whether the object might not be a comet at all, but an artificial one, a piece of alien technology passing through our solar system. Loeb was not new to this kind of claim. In 2017, he made almost identical arguments about Oumuamua, the very first interstellar object ever detected, citing its unusual, elongated shape and a small, unexplained acceleration as it left the solar system. Evidence, he argued, was at least consistent with an artificial origin, even though the overwhelming majority of the astronomical community concluded Oumuamua was very likely a natural, if unusual, icy fragment. With 3i Atlas, Loeb pointed to several details he considered worth taking seriously. Early size estimates, based on how much sunlight the object was reflecting, suggested it could be enormous, somewhere between 20 and 46 kilometers across, a size that, if accurate, would make it roughly 1 million times more massive than either of the two interstellar objects discovered before it. An outcome Loeb argued was statistically almost impossible for a naturally occurring object to achieve, given how little interstellar material models suggest should exist in that specific size range. He also pointed to a documented non-gravitational acceleration in the comet's trajectory, a small but measurable extra push beyond what the sun's gravity alone could explain. Loeb went as far as creating his own numerical scale, running from 0 to 10 to rate how likely an object is to be technological versus natural in origin, and placed 3I Atlas at a 4, a rating he described as reflecting genuine uncertainty rather than a conclusion. In later essays, he went further still, connecting 3I Atlas to something called the dark forest hypothesis, a concept borrowed from science fiction that proposes advanced civilizations across the galaxy stay deliberately silent and hidden from one another out of mutual fear, and speculating that the object's unusual characteristics might fit within that framework rather than a strictly natural explanation. It is important to be direct about where the rest of the scientific community actually stands on this because it is not a close call. The overwhelming consensus among astronomers studying 3I Atlas is that it is a natural comet, full stop. The comet displays a visible coma and tail, standard cometary outgassing behavior, and a nucleus size. Once more precise measurements came in from Hubble and other observatories, consistent with other comets, rather than the extreme outlier Loeb's earliest estimates suggested. Hubble's own imaging campaign, capturing the comet from a distance of roughly 277 million miles, allowed astronomers to place a far tighter constraint on its actual solid nucleus, separate from the surrounding cloud of reflective dust that had inflated the earliest brightness-based estimates. Once that dust was accounted for, the true nucleus turned out to be dramatically smaller than Loeb's initial worst-case figure, falling back in line with what researchers would expect from a large but entirely ordinary interstellar comet nucleus, undercutting one of the central pillars of the size-based argument for anything artificial. The non-gravitational acceleration Loeb pointed to has a well-understood natural explanation, the same one that applies to essentially every active comet ever studied. As ice near a comet's surface warms and turns directly into gas, that outgassing happens unevenly across the surface, and the resulting uneven thrust nudges the object's trajectory slightly away from a purely gravitational path, a phenomenon documented in comets throughout our own solar system for decades. Researchers who modeled 3I Atlas's specific acceleration alongside its measured size concluded that the amount of material it was losing through ordinary outgassing was entirely sufficient to explain the effect without requiring anything beyond basic cometary physics. But here's the detail that keeps this story from being a simple, closed case, and it is the reason serious scientific institutions, not just Loeb, decided this object was worth checking directly rather than dismissing outright. As 3I Atlas made its closest approach to Earth on December 18, 2025, passing at a safe distance of roughly 270 million kilometers, well over 160 million miles away, posing no threat whatsoever to our planet, the CD Institute and the Breakthrough Listen program, two of the most established organizations in the world dedicated to searching for genuine evidence of extraterrestrial intelligence, pointed the largest steerable radio telescope on the planet, the 100-meter Green Bank telescope in West Virginia, directly at the comet. Using 4 separate receivers spanning a wide range of radio frequencies, researchers scanned 3I Atlas for any sign of an artificial signal, a technosignature, anything that might indicate the object was transmitting rather than simply drifting silently through space. The search identified 9 signals initially flagged as worth closer examination. Every single one, after careful analysis, was traced back to ordinary human radio interference, satellites, ground-based transmitters, the everyday electromagnetic noise our own civilization produces constantly. No credible artificial signal of any kind was detected coming from 3I Atlas. The Green Bank observations were deliberately timed to occur less than 24 hours before the comet's closest approach to Earth, the single moment in its entire multi-billion-year journey when any hypothetical transmission would have been easiest to detect, giving researchers the best possible opportunity the laws of physics were ever going to offer them. As one of the researchers involved in the search put it afterward, the project's real value was proving how quickly and thoroughly modern instruments can check an object like this, demonstrating exactly the kind of rapid, rigorous response the scientific community will need as more interstellar visitors are inevitably discovered in the years ahead. So where does that actually leave us? An object that formed somewhere between 10 and 12 billion years ago around a star system that may no longer exist in any recognizable form, carrying a chemical signature dominated by carbon dioxide, unlike almost anything native to our own solar system, venting methane as it warms, drifting through our cosmic neighborhood on a trajectory that will carry it back out into interstellar space within the next couple of years, never to return, checked directly for artificial signals by 2 of the most credible SETI research programs on the planet, and found, as far as current instruments can detect, to be silent. Not a spacecraft, not a probe. As close to a definitive natural verdict as modern astronomy is currently capable of delivering, even while the man who first raised the alien hypothesis continues, publicly and persistently, to argue the question is not fully closed. Here is what deserves to sit at the center of this story, because it is the part that tends to get lost underneath the alien headlines. Regardless of how the debate over Avi Loeb's hypothesis eventually settles, the confirmed science alone is already extraordinary. We are, right now in 2026, looking directly at physical material that assembled itself into a solid object before our own sun existed. Chemistry preserved in ice for roughly 10 billion years, untouched, unmelted, drifting silently through the emptiness between stars until, by pure chance, its path happened to cross ours at exactly the moment in history when human beings had finally built instruments sensitive enough to notice it, catch it, and read its composition in detail before it vanished again forever. There is no version of this event that repeats on any predictable schedule. Oumuamua came and went in 2017. Borisov came and went in 2019. 3I Atlas is already on its way, out, and once it crosses back beyond the reach of our telescopes, whatever additional secrets its ancient ice still holds will leave with it, unrecoverable, for as long as human civilization exists. The next interstellar object to pass through our solar system could arrive next year, or it could take another decade. When it does, astronomers already know exactly what to do, because 3I Atlas proved the entire detection and response system actually works, from the automated sky survey that first spotted a faint point of light moving in the wrong direction, to the largest infrared telescope ever built, swinging into position within weeks to read its chemistry, to the largest steerable radio dish on the planet, checking, just in case, for a signal that was never there. Somewhere out in the galaxy, another ancient fragment like this one is already drifting toward us, carrying chemistry. From a star system we will likely never identify, formed at a point in cosmic history none of us will ever fully picture. The only question is whether we will be watching closely enough, and quickly enough, to catch it before it disappears again. If this kind of story is what you come here for, subscribe right now and turn on notifications, because we are going deeper into the edges of what science actually knows next time. Drop a comment with what surprised you most in this video, and share this with someone who needs to hear it, because this story deserves more than the silence it is getting.